Geometry, thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 10.5, angle relationships in circles. We'll be able to find the angle and arc measurements from those and also use circumscribed angles. First thing we've got going on is Theorem 10.14, so make sure we got our theorem sheet out. And this one's just talking about the tangent and the intersected chord theorem. If a tangent and a chord intersect at a point on the circle, so in this case we're looking at point A, that's our intersection point for the tangent and the chord, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Okay, so what we're looking at first is the measure of angle 1, which is here on the same side as arc AB. The measure of angle 1 will be half of the arc measurement for AB. So if AB is 100 and I'm just going to take a guess, 130 degrees, then the measurement of angle 1 would be half that, so 65 degrees, okay? Or the measurement of angle 2 is exactly half the major arc of BCA. Major arc BCA, if this is 130, then you just do 130 take away from 360, and that, let's say that that's 230 degrees. So angle 2 is just exactly half of that, which would be about 115 degrees. That was just an estimate. Take it for what you can. So what we're going to do is try to do those both. Line M is a tangent to the circle. Find the measure of the red angle or arc. If you want to pause these and try them on your own, I'm sure you can. When you're done, click play to check your work. So what we notice is the arc is 130, so that means our angle is exactly half, which I just did that example. Lo and behold, angle 1 is 65 degrees. Over here, 125 is the measurement of angle L, so our major arc, KJL, will be twice that amount. So the measurement of arc KJL is 250 degrees. Okay? Here's some more. If you need to practice these, go ahead and pause them. If not, we can go ahead and start going over these together. The measurement of angle 1 should be 105 degrees. The measurement of RST's arc should be twice 98, so that should be 198 degrees. And then the measurement of arc XY should be 160 degrees, because I'm just doubling that intercepted angle on that side. All right, let's talk about some intersecting lines on circles. So we have intersecting lines on the circle, inside the circle, or out of the circle. And these are two non-parallel lines in places where they can intersect, okay? So knowing that, we're going to talk about angles inside those circles formed from those intersecting lines. Theorem 10.15 is where we're going to start first. This will be a great addition to your theorem sheet. So let's get going with some drawings. Theorem 10.15 states this: two chords intersect inside of a circle. So here's my inside picture. Then the measures of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay? So that just means angle 1 can be found looking at arc DC and arc AB, adding those together because arc AB is vertical from angle 1 and dividing by 2. The measurement of angle 2 can be found by doing the arc AD, this one, plus arc of BC dividing by 2, because those are vertical angles, okay? So when you think about angles inside the circle theorem, I want you to think about using your vertical angles idea. This next one, Theorem 10.16, is angles outside the circle theorem. If a tangent and a secant, meaning something that is going through a circle, two tangents or two secants intersect outside of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. Okay? One way to remember this is, in order to find the measurement of your angle outside your circle, is just take 1/2 of your big arc minus your little arc. I'm going to say little arc. Okay? That will help you decide the differences there. okay? Because you can see with each one of these, we take the bigger arc minus the smaller one. So that's true here. BC is larger than AC. PR is larger, or PQR is larger than PR. And XY is smaller than WZ, okay? All right, so what we're going to do is try to find some of these measurements of angles. So the first one we have is x. I want to find the value of x. Remember, x can be found by taking 1/2 of the intercepted arcs vertically. So 156 plus the other one, 130. Okay, 156 plus 130 is going to give me 286. And then I'm just going to take half of that, so dividing it by 2, x is about 143 degrees. Okay, here's an outside of the circle, so x can be found by taking 1/2 of big arc, 178, minus small arc, 76. 178 minus 76 is 102, and then half of 102 is 51 degrees. Okay? Let's try these on your own. So let's pause the video here, try them, and when you're ready to check, click play. All right, so this one's a little different because you're focusing on y, but if you notice, y is not, we're missing this piece right here. So one thing we can think about is AC is maybe making half of that circle, so that's 180. So what I could do is take 102 from 180, and my leftover amount is 78 degrees, okay? Which means this is also 78 degrees, yes? So 78 degrees, because that's your interior angle, is equal to 1/2 of whatever 95 degrees plus y degrees is, okay? What I'm gonna do first is, I can do a few things here. You can distribute the 1/2, but I'm gonna not do that because I don't want 1/2 also being with y. So what I'm gonna do is multiply both sides here by 2, which means the 1/2 gets canceled out and all that's left is 95 plus y here, and then 78 times 2 is 156. So now all I have to do is just subtract 95 from both sides, and I'm gonna get 61 for y, okay? Next, here I have my angle, so 30 degrees is equal to 1/2 times the larger arc, A, minus 44. Again, to make my life more simple, I'm going to multiply both sides by 2. So 60 is equal to 1/2 times 2 is bye-bye, A minus 44. I'm going to add 44 to both sides. A is equal to 104 degrees. Okay? A circumscribed angle is an angle whose sides are tangent to a circle. Cool. It's like the angle is giving the circle a little hug. So, a circumscribed angle theorem just states the measure of a circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc. So here, ADB minus 180 is, or it can be found by taking 180 and subtracting the measurement of ACB, so this angle right here. So this is equal to 180 minus that, okay? Good picture to draw with its proper labels. Pause the video if you need to here. When you're ready to try some, click play. All right, so what we're gonna try to do is find the value of x. Notice x is on the outside, so that's my circumscribed angle, is equal to 180 minus this intercepting arc right here, 135. So x is equal to 45 degrees. Okay, here I can find it by saying 30 is equal to 180 minus x. Yeah. The only thing is when I start to move these things, I'm going to get negative 150 is equal to negative x. So then I just have to switch it over that x is equal to 150. But now I'm seeing this, that it's not showing the angle measurement that I need, because what I need is this angle right here. So what I just found was 150 for this angle measurement. So that's angle FGE. Okay. Instead, I need to take half of that. So x is exactly 1/2 of 50 because it's on the interior of that. So x is equal to 75. Okay? Next up, the northern lights are bright flashes of colored light between 50 and 200 miles above Earth. A flash occurs 150 miles above Earth at point C. What is the measure of arc BD, the portion of Earth from which the flash is visible? Earth's radius is approximately 4,000 miles, already marked. Okay? This is going to take us back to the very beginning when we talked about 10.1 and that bisector. Okay? So we know that CB and CD, those segments, are tangents. Okay? So that also means they are perpendicular to AB and AD. Okay? We also can say BC is congruent to CD using Theorem 10.2. So triangle ABC is congruent to triangle ADC. Okay? Knowing that, then we can maybe think about what is the measure of arc BD? Well, if we maybe find the angle measurement of this guy or the angle measurement of here, then we can find out the measurement of that entire degrees. So let's maybe think about the cosine of A because we're given 4,000 and 450, so that's adjacent to hypotenuse. So the cosine of A can be found if we take adjacent 4,000 over hypotenuse 4,150. So that means to find the measurement of CAD, I can find cosine inverse of 4,000 over 4,150. That's going to give me about 15.5. Okay? So the measurement for BAD, that would just be the entire thing. So 2 times 15.5 would give us about 31 degrees. So if the measurement of angle BAD is 31 degrees, then that also helps us find the arc of BD being 31 degrees. Okay? Boop. Next, find the value of x. So let's keep moving right along here. These are our last two to try. If you'd like to, go ahead and pause this video, and then we'll try and see how you did once you're done. All right, so number 6, we have x is equal to, here's my angle facing the circumscribed angle, so that's just 180 minus 120, so x is equal to 60. Okay? For this one over here, you've got two separate things going on because your circumscribed angle does not have this angle facing it, PRQ. So in order to find x, we got to think about it'll be 1/2 of the measure of angle PQ, right? So in order to find that, I'm just going to subtract 50 from 180 first. So this should be 130 degrees. So 1/2 of 130 is 65 degrees. Okay, so the measurement of angle PRQ is equal to 180 minus 50, which is 130, which is what we got initially. Okay. Last one, promise, I forgot about this one word problem. You're on the top of Mount Rainier on a clear day. You are about 2.73 miles above sea level at point B. Find the measure of arc CD, which represents the part of Earth that you can see. So this is where we would want to use our inverse cosine. So if we maybe think about this as x right here, x can be found by taking the cosine inverse of 4,000 over 4,002.73, and that's going to roughly give us about 2.11. So the measurement of arc CD can be found by taking 2 times 2.11, which would be about 4.22 degrees. Okay? Because we're just doing double of those x's, right? That'll be all for today on lesson 10.5, angle relationships in circles. Thanks so much for tuning in, geometry. Hope this video gives you a boost of confidence there. Tune back in next time when we talk about some segment relationships in circles. Have a great day.